Okay, here's the wild thought for you. Have you ever just stopped and wondered what would happen if the universe's lights just went out? I'm not just talking about our sun, I mean every single star. It's a question that takes us right to the edge of what we know about physics, and honestly, it makes us think about the ultimate fate of, well, everything.
So let's really dive in. What would actually happen if, in one single bizarre instant, every star in the universe just blinked out? All of them, at the exact same moment.
And the way our source material puts it is just perfect. This isn't just about a darker night sky. We're talking about imagining the death of light, of energy, of the entire cosmic structure itself. It's literally the end of the universe as we know it.
But here's where it gets really interesting. This whole cosmic shutdown, it wouldn't actually happen for us all at once. The end would kind of roll in waves. A slow, creeping darkness that's all dictated by one of the universe's most famous rules, the speed of light.
Think about it like this. Every single star you see at night is basically a history lesson. You're looking at a snapshot from the past. That's because light, even though it's incredibly fast, still takes time to get from there to here. So when you look up at the stars, you are quite literally looking back in time.
Let's start right here, at home, with our own sun. If it were to just vanish right this second, we wouldn't know a thing for a full 8 minutes. That's how long its last rays of light take to travel to Earth. So for 8 whole minutes, everything would feel normal, while our planet was busy orbiting a ghost, warmed by the light of a star that was already gone. Kinda spooky, right?
Okay, so let's zoom out a bit to our nearest stellar neighbor, Alpha Centauri. That star would disappear from our sky 4.2 years after this big lights out event. Can you believe that? For over 4 years, we'd still see its light twinkling up there, like a final postcard sent from a star that was no longer there.
And this is where the scale of it all just becomes mind-blowing. The light from the Andromeda Galaxy, our closest big galactic neighbor, takes 2.5 million years to reach us. I mean, entire civilizations could rise and fall in the time it would take for us to even realize its stars had gone dark. The night sky would just fade away piece by piece over millions and millions of years.
All right, but let's bring it back home, back to that 8-minute mark. Because once the sun's light and, maybe more importantly, its warmth finally stop arriving, the consequences for us here on Earth would be immediate, and they would be absolutely catastrophic.
The whole system would collapse like a house of cards. First, the instant the sunlight vanishes, photosynthesis just stops, dead. That's the engine for almost all life on Earth, just switched off. Then, within weeks, temperatures across the planet would plummet way below freezing. And finally, our oceans, the planet's great heat reservoir, would start to freeze solid, eventually encasing the whole world in a thick shell of ice.
Now, let's zoom back out to the bigger picture. Because while Earth is turning into a giant snowball, something way more fundamental is happening to all those stars themselves. Their very structure is failing, everywhere, all at once.
See, a star's entire life is defined by this one principle, hydrostatic equilibrium. You can think of it as this constant, titanic battle between two cosmic forces, a perfect balance that keeps stars like our sun stable for billions of years.
So on one side, you've got this incredible outward pressure from nuclear fusion happening in the star's core. It's trying to blow the star apart. But on the other side, you have the star's own massive gravity, relentlessly trying to crush it all inward. So what happens if you suddenly turn off the fusion? Well, it's not a battle anymore. Gravity wins, instantly.
And when gravity wins, every single star collapses. The really massive ones, they implode into black holes or these unbelievably dense things called neutron stars. And smaller stars, like our sun, would just shrink down into these cold, dead embers called white dwarfs. Our brilliant, beautiful Milky Way would become this silent, invisible graveyard, just a collection of these gravitational ghosts orbiting in a perfect, endless night.
And remember, this isn't just happening in our galaxy. It's happening everywhere, in every galaxy. It's pushing the entire universe toward what scientists think is its ultimate final fate. Physicists call it the heat death of the universe. It sounds dramatic, but it's really simple. With no stars making new energy, everything just cools down. The grand, beautiful structures of the cosmos would slowly decay. The universe's temperature would get closer and closer to absolute zero, as cold as it's possible to get. And entropy, which is basically just a fancy word for disorder, would hit its absolute maximum. It's a state where everything is perfectly, evenly, and coldly spread out. No structure, no heat, no life.
Now, in the real world, this whole process, this degenerate era, would be an incredibly long goodbye. We're talking about 100 times trillion years for even the last, longest-burning little stars to finally flicker out. And even then, it would take a number so big it's hard to even write down, 10 to the power of 100 years, for the last supermassive black holes to finally evaporate away into nothing. It's a timescale that's just beyond human comprehension.
It's really easy to hear all of this and think it sounds incredibly bleak, right? A tragic end to everything. But there's another way to look at it. There's actually a strange and kind of profound beauty in this final darkness.
And that's really the key takeaway here. This final darkness isn't some cosmic accident or failure. It's the ultimate fulfillment of the laws of physics. The universe isn't falling into chaos, it's settling into its most stable, most peaceful state. A perfect, cold, and quiet equilibrium.
And this is where it all comes full circle, right back to us. The very atoms that make up you, me, our planet, everything we've ever known, they were all forged in the fiery hearts of stars that died long, long ago. So in a very real way, we are the legacy of starlight. And even on a totally dark universe, that memory, that legacy, would still exist.
So I'll leave you with this to chew on. Is this ultimate fate really a tragedy? Or is it something else? Is it just the universe finally finding its most natural, most elegant, and perfect final balance? Something to think about.